Hi, this is second video for assignment 3, question number 9. First, let's look at this pole 0 diagram 1. From this diagram, we may write the transfer function like this. It may like this, and we can calculate the impulse response. It will be like this. So let's look at this equation. So the impulse response equation is like this. So the diagram of the impulse response must be like one signal response is at top and one is at bottom, or like all on the bottom. So let's find this response. So only the impulse response 6 matches these rules. So because it has the signal response, one is at top and one is at bottom. Yeah. And let's go to the second diagram. The second diagram, from this diagram we can write a transfer function, maybe like like this. So this is and we can calculate the impulse response. It is 0.7 powered by n multiplied by un. And this diagram must be monotonically decaying. So only the impulse response 1 matches this rule. So the diagram 2 is matched with response 1. Let's talk about the third diagram, pole diagram 3. We can, from this diagram, we can write the transfer function like this. Z minus alpha multiplied by Z minus alpha, Z minus 9. And I must say this is just from the diagram, not the exact number. So we have this transfer function, so we can calculate the impulse response. It will be like this. So from this response, we can say that it will be decaying sinusoidal. So we can say the monotonic decay term move the decaying oscillation term away from the center. Only the impulse response number 7 matches these rules. Move the center, and this is also decaying. Now we go to diagram 4. In diagram 4, let's talk about diagram 4. We can find the diagram 4. The WO is likely to be pi divided by 10. So we can calculate the WO, calculate the time for one circle, and for one period of time is like 2 pi divided by WO equals 20. So the period of time for one circle is 20 seconds. So we can find the impulse response. It matches response number 5. Yes, the period of time is for one circle is 20 seconds, so it's impulse response 5. Now we go to pole 0 diagram 5. In this diagram, we can find, and we can just talking this diagram with the diagram 6, because we can see they have the same angle, so they have the same time period of time for one circle, that is looks like pi divided by 5, so the time will be 10 seconds. But we can find some differences between the diagram 5 and diagram 6, because the radius of the pulse is less than 6, so they may have the same frequency, but diagram 5 is decaying lower than, so the diagram 5 maybe decays faster than diagram 6, so we can find that diagram 5 will match its impulse response 2, and diagram 6 will match its impulse response number 8, because we can see the frequency is the same. Yes. Now we go to the diagram number 7. Actually, we can find the diagram 7. The angle is very big, so the W must be very big, like something pi divided by 2.5, and maybe, so if we get a WO, we can calculate T equals 2 pi divided by WO equals 5, and the period of time for one circle is around 5, so we can find it may be like impulse number 3. We can say the period of time for one circle is 5. It's like 5. You can look at this. So we go to the last pole 0 diagram 8. Actually, diagram 8 is very easy, because we can see the pulse is out of the unit circle, so that means this system is unstable, and only the impulse response 4, this is unstable because it always diverges. And this is question number 9. Thank you.